Several times in this lesson, we've alluded to validating the data the user supplies in a form before sending it to your CGI. And this is for several reasons. You want to make sure your data is as accurate as possible. It keeps network traffic down, and you don't want to spend server resources handling bad data. Also, you want to make sure the user is not sending data that can cause problems on your server. Don't get hacked. And while the browser can do some simple checking, for example, making sure required fields have some data in them, validation is done mainly through JavaScript routines. So in this session, we'll be seeing how we can minimize problems before actually transmitting data to your CGI. We've already seen some validation capabilities that are built in to HTML. The required attribute causes HTML to ensure there is at least some data in an element. The URL and email types cause some rudimentary format checking to ensure data looks like a web address or email address, respectively. The range type can limit the possible values submitted. The min-length attribute can be used to ensure at least a specific number of characters are provided, and the max-length attribute can be used to limit the amount of text entered. Checkboxes and radio buttons can only carry predetermined values. Other checking can be quite problematic, but we do what we can. Here are some kinds of checking you can do. Is a specified value in an acceptable list? And this will be handled in the next lesson where we look at select elements. Is a value that is supposed to be a number actually a number? Does a text string contain characters not commensurate with the data it is supposed to hold? For example, does a family name field contain special characters like exclamation point, @ hashtag, $, and so on? Does the value contain dangerous data? What does that even mean? Not all possible errors can be detected, and checking on the client browser is just the first line of defense. There's expected to be some checking on the server side also. Also, note that the impact of any errors depends on how the data is to be used. If it will just be displayed and not kept, danger is pretty low. But if it will go into a file or a database, the potential damage is greater. And at this point in the learning process, we don't even know what all can go wrong. So let's look at some tools and techniques that can help. Use the types and attributes just mentioned where they fit. Look at some JavaScript string handling functions and use JavaScript logic to catch disallowed characters. We'll start by demonstrating a way to hack a form using very simple code. So here's the code for a form, much like we've been working with already. The usual kind of stuff, the doc type, the head, the body, sign up for our trip to Japan, and there's the form, and our action is a particular CGI with method get. And then a paragraph where we're gathering information. We have a full name and an email and a phone and a street address. And then another paragraph where we're asking for their age at the time of the trip. And then the usual kinds of stuff, watch for our confirmation email, and then a submit button, sign up, or a reset button. And that's the code. And here is the generated form. You can see what it looks like. And here's a demo of a possible user entering data and submitting the form. Now remember to view this from the perspective of being the webmaster. Suppose it is your form the viewer is filling in and submitting to your server. So let's see. I'll sign up as Bill Bluster. And my email will be bb@q.com. My phone will be 344-556. And my street address will be 567 9th Avenue. And let's say I'll be 34 and we'll sign up. And here's what you get from the CGI. Now I'll demonstrate using the same form and CGI in a malicious way. We'll back up, and after the full name, I'm going to add an A element. href equals bad page dot html id equals to bad, and then close the A element so there's no content, so it's not really visible. And then after the street address that I've entered, add a paragraph tag. And on click equals document.get element by ID, and then the ID we specified with the A element, and then a special method, the click method, on that element, and end there. And then click here to confirm. End of paragraph. So I've added text to the end of two text fields. Now I click on the sign up, and it looks the same as I had before, except this line here, click here to confirm. That was added by my nasty code. And when I click there, I'm sent to this bad page. At first I thought, how clever of me, and I was pretty full of myself and my hacker skills. But on reflection, I realized what was happening is that I just added some harmless code to the CGI's generated page. It's not even really a hack. No malicious software was installed. No user data was transmitted to a third party. Just a display of a page I wrote, bad page HTML. What can happen in a real hacking is one of these possible outcomes. Taking over your website by replacing the CGI with their own, say. Grabbing user data and transmitting it to a file on their site. Infecting your machine with malware. Now, I could not create a true hack in this situation because the CGI does not create or update data on its own server. More sophisticated CGIs are likely to be more vulnerable. So there's still a valuable lesson to be learned. For text and text-like types, set a max length attribute so there's not enough room for malicious data to get through. And a corollary, even so, check the content of text fields for possibly malicious strings. You can do this by not allowing, for example, a string that includes a less than character, the beginning of a tag. After all, there's no need for such a character in a user's name field or in an address. And these points will, indeed, inform our validity checks on our forms. So looking at text and text-like input elements then, we can see our first line of defense is to limit the number of characters the user can enter, max length equals. A vexing problem is, well, how do you know the maximum number of characters needed? If you're trying to be inclusive and international, you want to allow enough characters. And it might also depend on if you're collecting a single full name field or a family name field separate from a given name field, those sorts of things. Some rules of thumb for me. Any name field, allow a maximum of 60 characters. Email field, allow 40 characters. Address field, a max of 40 characters. City name, a max of 40 characters. State or province or prefecture names, a maximum of 40 characters. Mail codes or zip codes, max 11 characters. Country name, 40 characters. And phone numbers, 20 characters. And if and when anyone tells me it's too short, I'll expand the size. The next area of validation has to do with content of text fields, what characters should be allowed and which should be forbidden. And that, of course, depends on the particular content the field is asking for. For example, name fields should be allowed to contain the Latin alphabet, that is, lowercase and uppercase, A through Z. Spaces and digits, for example, Alfred space Winston III. Periods, for example, Mrs. MRS dot, unless you ask for honorifics in a separate field. Dashes, for example, Ms. Halicon days. For true international applications, you also want to allow characters from other languages, such as Arabic, Hebrew, Chinese, Japanese, Korean, and so on. The key here ties into the standard called Unicode. We've mentioned this in passing several times, but we'll go over the basics here. Unicode is the encoding scheme for HTML, CSS, JavaScript, and other web-related technologies. The home page for the standard is at http://www.unicode.org. The Unicode standard assigns a number to every character in every human language, as well as mathematical symbols, punctuation, currency symbols, even emojis. This number can be expressed as a decimal number, a binary number, or a hexadecimal number. We'll use decimal here. The interested student is directed to the latest code charts. To validate a text field, you can either make sure it only contains allowed characters, or you can ensure it does not contain any non-allowed characters. From a practical standpoint, you usually work with broad ranges of characters. For example, characters numbered 0 through 31 in decimal are control characters. 32 is a space. 33 through 47 are a mix of special characters. 48 through 57 represent the digits 0 through 9. 58 through 64 are additional special characters. 65 through 90 are uppercase alpha. 91 through 96 is more special characters, and 97 through 122 are lowercase alpha. So inside this range from 0 to 122, you disallow characters depending upon the intended usage. For example, the characters assigned to numbers 0 through 31 are disallowed in all fields. 32 is a space. It's allowed in most fields. 33 is the exclamation point. Disallow that in names and addresses. 34 is a double quote. Disallow that in names and addresses. Number 35 is the hashtag, #, number sign. Disallow that in names, but possibly in addresses are okay. 36 is the $sign. Disallow that in names and addresses. The 37 is the %sign. Again, disallow that in names and addresses. 38 is the ampersand. Allow that in business names or when two people use the same form. 39 is the single quote or apostrophe. Allow it in people and place names. O'Neill, O'Neill Street. 40 is the open parenthesis. You might allow it in names like Catherine parentheses Kitty. 41 is the closed parenthesis, same as for open parenthesis. 42 is the asterisk. Disallow that in names and addresses. 43 is a +sign. Disallow that in names and addresses. 44 is the comma. Disallow in names, but allow in addresses. 45 is the dash or minus or hyphen. Allow in names and addresses. 46 is the dot or period. Allow that in names and addresses. 47 is a slash, also called solidus. Disallow that in names, but allow it in addresses. Then 48 through 57 are the digits 0 through 9. Allow it in addresses, perhaps in names. 58 is a colon. Disallow in names, but allow in addresses. 59 is a semicolon. Disallow it in names and addresses. 60 is the less than symbol. Disallow that in names and addresses. 61 is the equal sign. Disallow that in names and addresses. 62 is the greater than sign. Disallow in names and addresses. 63 is a question mark. Disallow in names and addresses. Well, you might consider for a business name. 64 is the @ sign. Disallow it in names, allow for addresses. Then 65 through 90 are uppercase alpha. Allow those everywhere. 91 is the open bracket. Disallow it in names and addresses. 92 is the backslash or reverse solidus. Disallow that in names and addresses. 93 is the close bracket. Disallow that in names and addresses. 94 is the circumflex. Disallow it in names and addresses. 95 is the underscore. Disallow in names and addresses. And 96 is the backquote. Disallow in names and addresses. And then 97 through 122 are lowercase alpha, and allow those. For characters greater than 122, I generally allow. This is what I call practical laziness. While not all of the more than 130,000 characters make sense in names, the math symbols, music symbols, emoji, to name just a few, none can cause hacking trouble. And more detailed character filtering is not justified by the makeup of my audience. Also, while this table is tedious to construct, it provides us with a handy reference chart as we go about our work. Now we need to learn how to use JavaScript to scan text, to look at characters to determine if they are either allowed or disallowed. The first step is to recognize that JavaScript can treat text strings like arrays. So a string has a length attribute, and individual characters can be examined by stepping through the array until you have processed length characters. JavaScript includes many functions to work with strings. The function char code @I takes a look at the ith character in string and returns the Unicode number assigned to that character, perfect for our use. For our validation purposes, then, we'll build a function to step through a string one character at a time using the for construct and the char code function. The validation function will be passed a single argument, the string to be validated, usually the value property of an input element. One such function might look like this. Function is valid name in string. And then a comment, we're going to allow 0 through 9, lowercase a through z, uppercase a through z, space, dash, and period. Notice then we define the function with the surrounding braces, and within that we grab the length of our input string, and then the for statement steps through all the characters in the string, beginning at offset 0, incrementing one at a time until you've exceeded the length of the string. And within that we say, all right, let's assign to char num the character code at the ith location of our input string. And we ask if char num is less than 32, and if so, we return false. That is, we disallow characters before space. Else, and now the question is, what do we do? And notice at the bottom, by default, we're going to return true. Note that when a return false statement is encountered, control is passed back to the point where the function was invoked or called, and the result of the function is considered false. A return true statement returns control to the same point, and the result of the function is considered true. Usually, when the function returns false, the whole form submission is terminated to let the user correct the error. When the function returns true, the form submission proceeds, and we'll come back to this. So, what's next? We determined that if the current character is a control character, we're done. But what if the current character is not one of the control characters? Well, we keep on going down the list of characters and the assigned numbers. Next up is space, 32. And we want to allow that. And then we see that 33 through 38 are characters we don't want to allow in names. Exclamation point, double quote, pound sign or hashtag, dollar sign, percent sign, ampersand. So we code this. On the else we put the comment allow space, and now we say if char num greater than or equal to 33 and char num less than or equal to 38, notice the comment that disallows these characters, return false. Else, and now we're going to allow the next character, which is an apostrophe, 39. And then we say if it's not that, if its char num is greater than or equal to 40, less than or equal to 43, we're going to disallow open and close paren, asterisk, and plus sign. So we return false. Otherwise, and now we're going to allow the comma, dash, and period. So the next if says, well, if char num is 47, which is the slash, return false. Else, now we're going to allow 0 through 9. So we skip from 47 up to 58, because 48 through 57 are the digits. And then 58 through 64, we disallow those characters, return false. And then we go to the uppercase alpha, we jump up to 91, and then 91 through 96 are characters we don't want, so we return false. And then we allow everything after that. So we examine each character in this text field and ask if its assigned number maps to one of the allowed or disallowed characters. Once we find a disallowed character, we end the function and return false. It's only if all characters are in the allowed list that we return true. Now, to validate the email input element's value, we'll rely on the browser's built-in checking. So let's consider validation of the phone input element. The browser doesn't do any checking, and since there are many ways to enter phone numbers, all we can do is some basic content checking. Let's allow the space, digits 0 through 9, the dash, the period, the parenthesis, and the letter X for extension. There are, of course, many ways to refine this, but this is the choice we'll make for this example. So here's our code. It's structured pretty much like the previous example. Here we call our function isValidPhone, and we're going to pass the value from the phone number input element. And here's a comment specifying what characters we're going to allow. And then we walk through the string as we did before. So if characters are less than space, we disallow them, we allow space, and then we disallow a bunch of characters, and we allow the parentheses. And then we disallow a bunch of characters, and we allow the dash. And then we disallow a couple of other characters, and we allow the digits, and then we disallow everything up to the letter X, and we allow the letter X, and we disallow everything after X. Note that this does not validate format. If the user entered right paren, left paren, left paren, left paren, it would pass this test. This just makes sure only allowed characters have been entered. So this is a pretty basic form of validation. The street address field, in turn, will need to be checked also. Note that we can't use the routine isValidName because we allow a few more characters in street addresses than we do in names. We leave constructing isValidAttr up to you. So now we have presumably 3 validating routines: isValidName, isValidPhone, isValidAttr. Each takes a single argument, which is the value of an input element, and returns true if all the characters are allowed, or false if any of the characters is from the list of disallowed characters for that field. So now how do we use these functions? The point in time to invoke the validation routines is when the form is submitted. Submit is an event unique to forms. The event is raised when a submit button for the form is clicked. So invoke the data validation in an onSubmit event handler. But we have 3 validation steps, each of which has to have an input string. Kind of messy. So it's most common to invoke a single function that in turn invokes all your validation routines. So this main validation routine, let's call it checkVals, might look like this. Function checkVals if and then we have 3 if statements checking the returns from each value. And then in the form start tag, you're going to say onSubmit equals return check vals. Now let's walk through that check vals routine a little. First, you want to test the contents of the name field. So you get to the name field using document.getElementById parentheses quotes FM, because FM was the ID for the full name input element. Next, you access the value of this element by using the .value property. And if you want to run this value through the isValidName function, you say isValidName parenthesis document.getElementById fn.value. Finally, recall that running this function returns true or false. If the functions return false, the data is bad, so you want to return false for the checkVals function itself. That will cancel the submit. So we say if not isValidName document getElementById fn value return false. That is, if the value returned from the isValidName function is not true, then return false for the entire checkVals function. If the first test returns true, then control falls through to the second test, and so on. If all tests return true, the checkVals function returns true, and the submit continues. So what happens is control elements with the required attribute are checked to ensure there is at least some data in the value. Control elements with the min length and/or max length attributes are checked to ensure these criteria are met by the value. Input control elements with types URL and email have their value properties checked for valid formats. And then any onSubmit event handler is run. Now, if the browser validation finds an error, it issues an error message and moves the focus to the field in error. But our checkVals routine does not do that. Let's add that functionality. To issue an error message, we use the alert function. To draw attention to the field in error, we use the focus method. When an element has the focus, that is where the next keystroke or mouse click will be sent. We can cause the focus to move to an element by using the focus method. So let's add a message and then set the focus for each error. So here we have modified our checkVals by adding an alert and a focus method invocation for each of the 3 checks. Notice that since the true path of the if statements now have multiple statements, these statements must be set off in braces. There's one other method for input elements that might be useful, the select method. This method selects the complete content of a field. If the user begins typing, the selected data is deleted and the new data is entered. If instead the user uses the mouse or arrow keys to change location, the selected data remains. The selection is usually indicated by highlighting the whole field, like this. So the combination of moving the focus and selecting the content prepares the user for correcting any error in the input field. So now we've added the select method in each of our if statements. So we put the functions isValidName, isValidPhone, isValidAdder, and checkVals in a script element, and add the onSubmit event handler in the form start tag, and we're ready to do some good validation of the values the user has entered. The code, while not large, is a bit tricky. Quotes, parentheses, braces, and brackets all have to be correctly coded and matched. Careful indentation can help you with a visual check. Still, extensive testing is recommended. The good news is, once you have these routines working, you can put all the isValid XXX functions in one external script and use them in many pages that have forms. In this session, we looked at techniques for validating data the user has entered, built-in checking supplied by the browser, setting maximum length values, deciding which characters should be allowed, then coding functions to check the contents of input fields to ensure they only contain allowed characters. Coding a function for the onSubmit event to invoke your validation routines, and helping the user find and correct bad data by using the focus and select methods. While there is no complete and foolproof way to guarantee total correctness, those silly users will be careless, and some will be malicious. We can greatly reduce the chances of hacking from data entry and minimize incorrect data going to our CGI on our server. In the next lesson, we explore additional control elements and some supporting elements: button, select, option, opt group, label, text area, field set, and legend. See you there.